Hello, everyone. Thank you for coming to our Day of Data Science event. I'm very glad to have this opportunity to talk to you. So my name is Ting Xiao, and I'm an assistant professor of data science. And the topic of my talk is knowledge beyond language with vector embeddings. Okay. So we live in a rich sensory world. There are tons of data, and eventually we distill that data into valuable information. Much of that information can be expressed in words, but a lot of it can't. For example, the tone of that voice, that body language, the style of a painting. So how do we extract and utilize that nonverbal information? How do we store and organize the extracted knowledge without having to passing through the bottleneck of text? Well, this is fairly vague, so let me give you a few examples to pin this idea down. Okay, so I'd like to pose a few questions to explain what I mean about information, the nonverbal information available in the data, and how do we use them. So for the first one, which image is more like the black chair? Well, if we look at that black chair, we have a latent understanding that it's a chair. So it's really easy for us as human beings to answer that it's more similar to another chair than to a table. But we could do this even without language in cases where the chairs don't look similar at all. And for the second one, what companies are most like Tesla? In other words, how do we build an understanding of companies and their relationships? Well, this is a little harder for us to answer. But both questions can be readily be answered with one approach, vector embeddings. So what is a vector embedding? A vector embedding is a way of representing an item with a list of numbers, where similar items have similar numbers. Let's start by looking at the figure on the top right. So in that square, cat and kitten are close to each other, while houses is farther away. Word embeddings makes it so that when someone searches for cat on Google, we'll probably get some pictures of kittens, which is exactly what we want, right? Vector embeddings also have the ability to preserve relationship or relative meanings. So in the picture at the bottom right, a classic example is if you take woman and subtract it from man, and then you add it to king, you'll get something better than a king, which is a queen. So the secret sauce of today's vector embedding is that it can handle representations with dimensions much higher than before, which makes quality word embeddings possible. However, the strategy to create these representations don't assign meanings to the dimensions. So we'll talk about how to use them effectively. Okay, so from words to images, now we have the ability to create representations from images of objects. So in the figure at the bottom, we can take those images of chairs and then encode them into these latent representations and reconstruct them from these latent representations. So it's much easier to reason about such latent representations. And you can even do cool things, like the imitation on the top in the middle. So if you draw a line between two latent representations, then you can create intermediate versions. Take points from the latent space, you can create furniture that no one has ever seen. And if you link word representations to visual representations, you can even act the system to create an avocado armchair. On the top right, that was what OpenAI's GPT-3's variant for image was able to do. And now we have GPT-4, we can do even better. Okay, so now let's talk about the companies. So this next one is a little hard to think about. Companies don't really have images to process. So how do we build a representation for images? So here I'm going to introduce a pretty simple but a clever way to do that. So companies vary in many ways. Some are easier to measure, like the industry segment, weather, local population, but others are harder to quantify, like the regulatory environment, corporate culture, corporate structure. However, we do know that a company's stock can be sensitive to many of these features. So an embedding of stock price movements can probably tell us more about the company than just the stock information. So this is what we did. We take the data from 5 years S&P 500 daily stock change. Then for each day, we rank the stock from the highest change to the lowest change. So in that way, we create a sentence. So for each day, we have a sentence. There are about 1,200 companies. Each company name or stock name is a word, and we rank it from the highest change to the lowest change of stock price. So for each day, we have a sentence, and we have 5-year stocks data. So that gives us about 1,800 sentences. Then we apply a standard word embedding approach called word2vec to these sentences to create representations of the stocks that try to preserve the order in each sentence. And then we evaluate the dimensionality by classifying the industry. So there are about 11 industry sectors. And if you look at the figure on the top right, that is the performance of the embeddings as a function of the number of dimensions. And we pick 4 dimensions since that's the fewest dimension that seem to get a decent performance. Okay, so we use the 4-dimensional representation, but that's still too much to visualize. So for the purpose of visualization, we further decrease the dimensions to only 2. So in the figure on the left, you can see that each dot represents a company or a stock. And if we color code each company by its industry sector, you can see that it actually does an okay job separating certain industries. And remember, the colors are from the knowledge of which company, like which industry each company belongs to. But the locations are purely from the stock price fluctuations. And in its original 4 dimensions representations, these companies are separated even better. Moreover, the vector embeddings are not just useful for finding similar companies, like the question we asked before, which company is more like Tesla. It is also a gold mine for machine learning problems. So for example, in the figure on the right, we create a simple model trying to predict the environmental, social, and the governance rating, or ESG rating, first without the embeddings and then later with embeddings. And as you can see, simply adding that 4-dimensional embeddings significantly improve the performance. Yeah, so you actually can extract a lot of information from stocks than you think using the vector embeddings method. Okay, so in the last few slides, I'd like to introduce some of the student programs I'm currently leading or co-leading. So for the first one is the NSF REU site based on the same theme, so vector embeddings. This one is a 10-week summer program, mostly for non-UNT undergraduate students to come to UNT to do some research. So for this year, we'll have it from late May to the end of July, and they will offer it in the next few years as well. However, students have to be US citizens or permanent residents, but they will offer 6,000 stipend and housing, free housing. The select students will participate in the UNT AI Summer Research Program, which I will talk about in the next slide. They will work with faculty and other students for a fun and a productive summer experience. Okay, so this AI Summer Research Program is a 4-week intensive research team effort to bring students from a variety of AI-related academic programs. That includes both undergraduate students and graduate students. And we have run it every summer for a few years. So for example, in last year, we had 56 students working on 17 projects with the help of 8 participating faculty. And this summer, we'll have 2 sessions. One is in May and June, and the other is in July. For these programs, all students can apply. So including international students, it's free of charge. However, you have to be there in person every day in the morning, at least in the morning for 4 weeks. And it's very intensive. You have to do a lot of work. Yeah, and for any faculty and the industry partner, if you have any project idea, you're welcome to talk to me if you want the students to work on that this summer. Okay. And yeah, and then lastly, I'm the liaison for this AI for All Discover AI program. So AI for All is a nonprofit national organization, and they have partnered with us to offer free courses for undergrad students. So currently we're offering the first step, Discover AI, which is an introduction to AI fundamentals. It is a 10-week online program, including both synchronous and asynchronous instructions. So this one is offered in the spring and the fall semesters, not in the summer, and only for UNT undergrad students. Again, international students are welcome to apply, and it's free of charge. So yeah, so if anyone is interested in any program, you can talk to me today or later this semester. And thank you for your attention.